This video is about confidence intervals for proportions. By the end of this video, you should be able to explain what a confidence interval can and cannot tell us. You should be able to explain what a confidence level is. You should also be able to check conditions and then find a 1 proportion z interval. And finally, you should be able to calculate the sample size needed when given the confidence level and the margin of error. First, I want to start this off with a context. So there is some coral reefs that are infected with a disease. And this doctor, Dr. Drew Harvell, and his team want to understand how pervasive this disease is. How many of the sea fans are infected with the disease? Okay, so they they randomly select 19 reefs and then go and collect samples from those areas, and they find that 54 out of 104 sea fans that they sampled were infected with the disease. Okay, so after they've done all this, the thing that they want to know is what percent of all the sea fans are infected. Okay, but that is not a simple question. Okay, even if you do everything correctly with getting a random sample, it's hard to tell exactly how many sea fans or what percent of sea fans are infected. Question using a sampling distribution, okay, as long as the assumptions and conditions are satisfied, which means that the sea fans are independent of each other, that the sample size is big enough to have a sampling distribution, that the sample was collected randomly, that we sampled less than 10% of all sea fans, and finally we expected to find at least 10 that had the disease and 10 that did not have the disease. Okay, now if those are satisfied, we can use a sampling distribution. Okay, specifically, we can use the standard deviation from the sampling distribution and estimate the standard deviation for the population. Okay, now whenever we estimate the standard deviation, it's called the standard error. It's the same standard deviation, standard error, but we have a different name for it because it's not the standard deviation. So we call it the standard error, even though it isn't an error. Okay, so using the equation from a sampling distribution, we find that the standard error is 4.9%. Okay, that from whatever the true percent of sea fans that are infected, that the standard deviation will be 4.9%. Now, because it follows the normal model, we know that 68% of samples will be within one standard error from the true percent of sea fans that are infected. That 95% of samples will come in within 2 standard errors of the true proportion, and we know that 99.7% of all samples will come in within 3 standard errors of the true proportion. Okay, now that doesn't really help us because we still want to know what that true proportion is. So what if we look at this from the perspective of p hat? Instead of thinking about the true proportion being a fixed number and p hat is somewhere in this distribution, what if we flip that around and looked at p hat being the center? We know what that one is, okay? And we think about, well, maybe the true proportion might be somewhere in here, okay? It's the same distribution, it's just kind of thinking it from a different perspective, okay? We would know that 68% of the time that the population proportion will be within 1 standard error of the sample proportion. Okay, and 95% of the time, the population proportion will be within 2 standard errors of the sample proportion, and 99.7% of the time, the population proportion will be within 3 standard errors of the sample proportion, which is a really important finding, because this means that we can decide what percent of the time the population proportion will be within our interval. Okay, What that also means is that if you want your interval to be narrower, you have to be less confident about it, okay? And if you want to be more certain that more often you will have the true proportion, your interval has to be wider. So it has to be in some kind of an interval. You can't have an exact answer, an exact number, but you can give an interval within a certain level of certainty. Okay? And the conclusion that you make if you use this equation of p hat plus or minus 2 times the standard error of p hat, then we can say that I'm 95% confident that between 42.1% and 61.7% of Las Adidas C fans are infected. Okay, that's the conclusion. And this is a phrase that you should get used to saying. Actually, this also should be underlined because you can change your confidence level, which we'll talk about in a few minutes. Okay, that I am blank percent confidence that between blank and blank of blank. Okay, that's a good phrase to have memorized as you will be giving conclusions for your confidence intervals. Okay, so what does 95% confidence really mean? Okay, when you say you're 95% confident that this is true. The 95% confidence comes in the process that was used to find the interval. Okay, the process that was used will produce intervals that contain the true proportion about 95% of the time. Okay, which means you'll usually have it in there, but it's possible that it's not. Okay, now we talked about this being an interval, so there is some kind of margin of error. Okay. Also keep in mind that the 2 that we've been using, the 2 standard deviations for a 95% confidence interval, is only, it comes from the empirical rule, which is an estimate. It's a rule of thumb. Okay. Now, to be more precise and more flexible with our confidence levels, we need to think about it as far as an estimate plus or minus some margin of error. Okay, so it's going to be an estimate, and the margin of error comes from some critical value that tells us how big or small it should be times the standard error. Okay, and right now I want to explain how to find this critical value. We've been using 2 to get a 95% confidence interval, but really can be more than just that. Okay, so let's first look more in depth about a 95% confidence level. Okay, that means if this is the center and I want the middle 95% of my data, that means in here is 95%. So on the ends, I have 2.5%. Okay, and I can find this value by looking at inv-norm of the 0.95 plus 1 tail, which would be 0.975. Okay, so if you grab a calculator and you do inv-norm of 0.975, you will find that the critical value is not 2, it's actually 1.96 is very close. Okay, so it's actually 1.96 times the standard error. Okay, and just to make sure that you really understand this, let's do it now a different one. Let's run through it again. And let's use something like 90% confident. Okay, I'm 90% confident that the true, proportion is within this number and this number. Okay, so the middle 90% of my data, okay, which means that there will be 5% on each end. Okay, which means this value right here will come from inv-norm of the middle 95 plus 1 tail. It'd be 0.95. Okay, so the critical value that we use will be inv-norm of 0.95, which gives us 1.645 as the critical value we'd use. Okay, so this will help you find larger and smaller intervals depending upon how confident you want to be with your interval. Okay. This interval that we're talking about and creating here has a name, okay? And it has a name because as we go throughout the year, we will find several confidence intervals, okay? And so we need a name for this one. And because we're dealing only with one proportion and we're using the normal model, think of z-scores, it's called the one proportion z interval, Okay, and so when the conditions are met, we are ready to find the confidence interval for the population proportion P, which has this equation, P hat plus or minus Z star, and Z star is the critical value that was discussed in the last slide, times the standard error of P hat, which comes from this equation that we discussed with sampling distributions. Okay, now with anything, there are some assumptions and conditions, and there are, again, these 5. Now I want to point out that on a AP free response question, the trend that I see almost every time is that when they're asking for confidence intervals, they're looking at 2 specifically, not all 5. Okay, so the 2 that you must kind of keep in mind that you must mention in detail is 1, the randomization condition. You must state explicitly why you know that the data comes from a random sample. And the second really important one is the success failure condition. You must actually calculate and plug numbers in. N, which is the sample size, times P, actually it'll be P hat, is bigger than or equal to 10. And N times Q hat is bigger than or equal to 10. Plug the numbers in, the sample size times the probability of success or failure, and make sure that that's at least 10. Okay, so choosing your sample size. Let's kind of take this from a different perspective. What if we knew that we needed to be 95% confident and we need to be within 3% of the true proportion? Okay, we could then calculate how big our sample needs to be, okay, using this formula right here. Okay, so we plug in that I need the margin of error to be 3% as a decimal. And our critical value, this comes from the 95. We discussed a little bit ago that I've had to get from 95% confidence to a critical value. Okay, and then we have P hat Q hat over N. Now the problem is we haven't taken our sample yet, and so I don't know what P hat and Q hat are. So the worst case scenario is that P hat is equal to 0.5. If you look at, like 0.1 times 0.9, as far as what possible P hat values could be, the worst case scenario is 0.5 times 0.5, which is equal to 0.25. You can't find any other P hat that has a P hat times Q hat that's more than 0.5. Okay, so if you use those values in our worst case scenario right here, and then use some algebra to solve for this, let me scroll down, you will find this number, 1067.1. And to be extra, make sure that you have it, you always round up. And so you need 1,068 respondents in order to have a 95% confidence interval that's accurate to within 3%. Okay, so it'd be nice to be 1% accurate, but in order to be 1% accurate, you would need a really, really big sample. This video was about confidence intervals for proportions. I'm hoping this exposed you to the ideas of what a confidence interval is and what it can and cannot tell us. We don't know for certain that we have an interval in which the true proportion is, but with a certain level of confidence, we can say it's in there. You should be able to explain what a confidence level is. What is meant by 90% confidence or 95% confidence? You should be able to check conditions and then find a 1 proportion Z interval. And also you should be able to calculate the sample size needed when given the confidence level and the margin of error. Thank you so much for watching.